Hello and welcome to yet another riveting video about geometry. And this is section 4, and this is a video about triangle similarity, what we did in section 3, but using a couple different things, using SSS and SAS, okay? And so what we want to talk about is showing triangular similarity. Now remember, triangle similarity indicates that triangles, okay, are the same shape, okay, but different sizes. Same shape, but different size. All right? And so remember that we need to say this, that the corresponding angles are congruent. So corresponding angles are congruent, and that corresponding sides are proportional. And that corresponding sides are proportional, okay? And so proportional. All right, so what I know about that is when I say sides are proportional, that means that fractions are equal, okay? That means that we have equal fractions, all right? And you'll see what I mean by that, okay? So equal fractions. All right, so what we want to do, let's first introduce the side-side-side similarity theorem. And what it says is that if corresponding side lengths of two triangles are proportional, then the triangles are similar, okay? So let's just say this, and I'm going to indicate some colors here and just kind of show you what's what. And what I know about this, let's start with our short segment over here, okay? AB corresponds with the shorter segment of this. Now we know that these two triangles aren't the same size, but I see that AB is the shortest side of this triangle, okay? The shortest side of this other triangle would be triangle ED, okay? And then it's kind of hard to see what BC and AC correspond with, okay? Whether they correspond with EF or DF. And so I'm going to do this, okay? I'm going to highlight BC because BC is the second largest side length in this triangle. And I know, if I look over here, it's kind of hard to tell, but what I know is that, you know, AB and BC kind of form this angle here that kind of looks like a right angle, okay? That's going to be the same thing over here. So what I want to say is that EF then corresponds with BC, okay? And then I'm going to do this. I'm going to highlight this in purple. Okay, I'm going to say that AC corresponds with DF. Okay, so you can see it on the paper, you know, on this, but let's just write this out so that we have it written down. I'm going to say that AB, that segment corresponds with ED. Okay, I'm going to then say that BC, okay, corresponds with EF, okay, and I'm going to say that AC, that corresponds with DF, all right. So when we say that the sides are proportional, that the corresponding sides are proportional, let's just do this, okay. I'm going to call this a 3, 4, 5 triangle. Okay, then what I would do, let's just say that the triangle is doubled, okay, that the side lengths are doubled. And I'm going to say that we'll just have n equal 2. So we go from this triangle to this triangle, the sides are doubled, so I'm going to say that this is a 6, sorry, 6, we'll call this 8, and we'll call this 10. Okay, now because my corresponding sides are proportional, okay, so what I would do then is I would set up fractions, okay, and I would say that, like, okay, if I take segment AB, which has a length of 3, okay, I would take that length 3, okay, and then I would set that over the corresponding side over here, which is 6, okay, so 6, all right. And then the question is that equal to, say, length BC, which is 4, being divided by length EF over here, which is 8, okay? And so is that equivalent? Okay, and then is it equivalent to the third side? Okay, and so then I would take segment AC, which is 5, okay, and then I would divide it by its corresponding segment, which is DF, which is 10. And I chose this example because this one's relatively easy, because you notice that every time you do this, if you take 3 6, 4 8, and 5 tenths, you know that all of those are the same thing as writing 1/2, okay? And so, that's one way of just verifying that they are proportional. So when you have this statement, you can say then, yes, they're proportional, okay? All sides are proportional, all right? And so the triangles are congruent, okay? And you could go the other way. You could take 6 over 3. Is that equal to 8 over 4? Okay, is that equal to 5 or 10 over 5? And if you simplified all those numbers, you get the same value of 2 over 1, okay? And that's the idea, is that you want to then, also say that, yes, they are proportional. And so then what you can do, okay, if you go back through and you say, yes, these are proportional, then you can say that triangle, and let me just say ABC, and let's see what corresponds with A. A corresponds with D. ABC, DEF, okay? So triangle ABC is similar to triangle DEF, okay? And you have to make sure that your angle measures, these points, correspond with each other, okay? Another way of doing this, another way of verifying this is by using what we call the cross product property, okay? So I'm going to do the cross product property, okay? Another way to verify. Let me just write that down, that this is another way to verify proportional. Okay, and so, if I think about those side lengths, if I think about those fractions that I have, like if I take 6 over 3 and set it equal to 8 over 4, the question is are these equal? Yes, you can sit there and you can do division and say, okay, this is 0.5, this is 2, this is 2. So yes, they are equal. They're not always that easy. So what I'd like to do is to do this cross product thing where I multiply 3 times 8 and 6 times 4. So if I do 6 times 4, is that equal to 3 times 8? Okay, and so 6 times 4, if I multiply those together, I'm going to get 24. And then 3 times 8 is also 24. So this is an equivalent statement, okay? And then if I take, say, 8 over 4, is that equal to 10 over 5, okay? And if I cross multiply those two together, okay, I'm going to do 4 times 10. Is that equal to 8 times 5? Okay, and so 4 times 10, if I do that, that's going to give me 40. If I do 8 times 5, that's also going to give me 40. This is a true statement, and there we go. Okay, so you can do it that way if you want, or you can just, set up all your fractions, okay, and see if you get the same decimal, okay, as a result. All right, so let's continue on. Okay, let's apply this theorem. Okay, it says, can the pairs of triangles be proven similar using side-side-side similarity theorem? So what I want to do is I'm going to come over here, and it doesn't matter which one you do, but I'm going to identify the shortest side of my first triangle, okay, which is 4. Okay, and then I'm going to say, all right, let's find the shortest triangle or shortest side of the second triangle, which is 6. So I'm going to set up a fraction and say 4 over 6, okay? Then I'm going to find my medium-sized side length, which is going to be 6, okay, and compare that to my medium-sized side length of 9, okay, over here on that triangle. So is 4/6 equal to doing 6 over 9, okay? And so, and then if I wanted to do 8 over 12, okay, take that one, that's the last one. Is this equal to 8 over 12? And so, if you did the decimal approximation, all of these are equal to 0.3 repeating, okay, which is the same thing as saying 1/3. Then you could then just say, yes. So let me do this. Let me say yes. They're proportional. So yes, triangle and let's just do RTS, triangle RTS is similar to triangle, and let's do XZY by the side-side-side similarity theorem, okay? And that's all you need to do, okay? You're just verifying, okay? Thing is, you need to be able to set this up. You need to have a number that you verify this with. You need to write your similarity statement and then how you know. What did you use, okay? All right, on the next one, okay, what I'll do is I'll say this, that the triangles on this one, kind of interesting. So I know that this length here, okay, is 5. I know it is also congruent to this length here, so I'll call this 5, okay? Now, in the same picture, it says that QP and QR are congruent to CD and DE respectively. So what I'm going to say that this is 5 and this is 5, okay? And then the last one, I know that PR is 9 and that CE is congruent to PR, so this must also be 9. So this is kind of weird, okay? And what I would say is, let's just correlate QR with CD. Let's correspond QP with DE. And then let's correspond RP with CE, okay? And so, what we can say here is that, if I take, QR, which is 5, and compare it to the length of CD, so if I do 5 divided by 5, is that equal to me doing 5 divided by 5 here? And of course it is. It's going to be 1. And then is that correspond with PR to CE? Is that equal to 9 over 9? And the answer to that question is, yeah, they're all equal to 1. So actually these are congruent. So they're not similar. Similar, remember, means that they have different sizes, by definition. So this one's kind of weird. You could kind of go either way on this. I wouldn't, I'm not going to be that nitpicky about it, but that's the idea. So you could say yes or no, but I would go ahead and just say yes, that if they are congruent, then they are similar, but if they're similar, it doesn't mean that they're congruent. So yes, triangle, and I'll do RQP. RQP is similar to triangle CDE, okay, by side, okay? And you could also make the statement that yes, triangle RQP is congruent to triangle CDE by side. Okay, you could do that same thing, okay? So let's go ahead and talk about the next one, which is the side angle side similarity theorem. And what that says, similar with what we learned about side angle side congruence theorem, was that if one angle of one triangle is congruent to another angle, so like I have angle A and angle D, and the lengths of the sides including these angles, so this length and this length and this length and this length are proportional, then the triangles are similar. So what I'm going to do is I'm going to come in here, and I automatically know that angle A and angle D are congruent. Okay, I also know that AB corresponds with DE. Okay, and then I also know that AC corresponds with DF. Okay, and so what I'm going to do is I'm going to go ahead and I'm going to call this length a 3 over here, a 4 over here, and then I'm going to call this one a length of 6, and call this a length of 8, okay? So here's what I know, okay? I know that angle A is congruent to angle D, okay? I also know that my length of AB, which is 6, okay, that corresponds with 3. Is that equal to this length here, 8, and its corresponding side, the ratio of those? So if I take 8 and divide it by 4, are those the same? And of course, we're going to get 2 as a result, all right? So yes, you could also multiply these together and say, okay, 6 times 4, is that equal to 8 times 3? And you get 24 equals 24, and the answer is yes. and you have an angle. But the idea, guys, remember that you have this thing where you have a side, an angle measure, and a side, and you have a side, an angle measure, and a side, okay? But, in this, you're just showing that, an included angle and, is congruent to another angle, and that the sides that contain that angle are proportional, okay? And that's all we're doing. All right, so let's continue on with this section, and let's apply the side angle side similarity theorem. And what we want to do is we want to say, okay, can we prove that these triangles are similar using side angle side similarity theorem? So what I know is that angle R is congruent to angle Z in this first one, okay? And then I know that PR, that corresponds with XZ. So I'm going to color that red, color this one red, okay? And what I know is I have the statement that if I take the ratio of that it's equal to the ratio of QR, this segment, and YZ, the ratio of those. So I'm going to take this and that side, okay? And because those are corresponding, okay, PR corresponds with XZ, and QR corresponds with YZ. If I take the ratio of these two and divide it by the ratio of these, then that's equal. And so what we then say is that triangle PRQ, so PRQ is similar to triangle XZY, okay? And that's what I know. And I know that by side angle side, okay? So then on the next one, what I know is that angle K is congruent to angle N, okay? Angle K is congruent to angle N. That's the first piece, okay? And then what I have is I have JL and MO correspond, okay? So JL and MO correspond with each other, and that JK corresponds with MN, okay? That JK corresponds with MN. And what I notice here is that these aren't corresponding sides, okay? This is not true, okay? These are not corresponding sides. All right, and the reason why I know that is because MN is the longest side, okay? This is my longest side, okay? It should correspond with JK, okay? That's the longest side. But what we're saying is that LK and MN correspond. So this is not corresponding, so these are not similar, okay? Not similar. All right, so we don't know. And plus the other thing is that we were given a side-side angle and a side-side angle. All right, so we don't even have side angle side. We had a side, and we had an angle. Here we had a side, and an angle, okay? Over here on this one, we had a side, an angle, and a side. We had a side, an angle, and a side. All right, and that's it. All right, so what I want to do is on this one, I want to apply the side-side-side similarity theorem, and I want to use coordinates to show that triangle ABC is similar to triangle DEF. Well, here's the beautiful thing about this, is that they want us to show this. They've already given us the part of the answers, folks. Okay, so I know that A corresponds with D. I know that B corresponds with E. And I also know that C corresponds with F, okay? So I'm going to kind of go in here and take a look at those real quick. I'm just going to do that real quick. A is this point here, corresponds with D, okay? B corresponds with E, okay? And then F corresponds with C. Okay, and I got all of that because of the way that it was named, okay? Now, what I know is that the length of EF, okay, is going to give me a length of, this goes by twos, so 2, 4, 6, 8. This is a length of 8, okay? I also know that the segment length of from here to here is 2, 4, 6, 8 as well. Okay. if I look over here, it's kind of hard to see, but the length here is, goes from a y value of 3 to a y value of 7, so this is a length of 4. Okay, and then this length over here is a length of 4 as well. Okay, so if I take ABC, if I take, the segment, say, AB, okay, which is 4, all right, I've got 4 over 4. I'm sorry, 4 over, what does it correspond with? AB corresponds with DE, okay, and that's a length of 8, so 4 over 8, okay. Is that equal to then CB, which is 4, okay, and then divide that by EF, okay, so those correspond, okay, and those are going to equal 1/2, all right, which is good, okay. And then if I were to find the length of that third side, I would need to use either the Pythagorean theorem or the distance formula. I know that this is a right angle, so I know that this is just going to be the square root of 4 squared plus 4 squared, which is going to give me the square root of 16 plus 16, so that's going to give me the square root of 32, okay? Now, if I simplify this, this becomes the square root of 16 times 2, which is, or I'm sorry, square root of 2, and so that's going to be 4 times the square root of 2. So this has a length of 4 square root of 2, all right, from that. And then if I do the same thing over here, this is going to be the square root of 8 squared plus 8 squared, which is the square root of 64 plus 64. Okay, the square root of, say, 128, and if I simplify that, I can separate that, I can divide that by 2, and it gives me the square root of 64 times the square root of 2, so I get 8 times the square root of 2. Okay, so this length here is 8 times the square root of 2. We will come back and do a lot of Pythagorean theorem stuff, all right, but what I know is that if I take the length over here, which is 4 root 2, 4 times the square root of 2, and if I divide that by this length over here, which is 8 times the square root of 2, okay, then I know that my square roots of 2's divide out, and I'm left with 4 over 8, which is equal to 1/2, okay? And so you're just looking for this verification. I'm looking for this work. You want to make sure that you can divide the side lengths and get the same ratio as all of these, and that's the idea, okay? And that's all I'm looking for. All right, on this one, what I want to show is that, okay, we're given a certain amount of information, and we're doing a proof here. What else this is the last thing. Let's go ahead and just stop this video. Video's kind of long. I can go over this one in class. You guys are good on this, and we'll talk about it later. Thanks. You guys did a good job. Bye.